Welcome to the first of our concept check videos. These will be a series of 3 questions that will follow the video lecture to make sure you've understood the basic concepts covered in that particular lecture series. For these concept check videos, I'll encourage you to pause the video on each question or each new slide, work through the questions yourself, then unpause your video for us to walk through the answers together. And if at any time you find that your answer doesn't match mine, I'd recommend that you stop the video and take another stab at the question before watching the correct solution. Okay, so here we go. Go ahead and pause your video and determine the geometry of the carbon indicated in the structure shown. Welcome back. The carbon indicated here has 3 groups around it, an oxygen, a methyl group, and an OH. So that carbon will be sp2 hybridized. It will have a trigonal planar geometry with 120-degree bond angles. Here you're asked to draw a pi bond resulting from the overlap of 2 p orbitals. We'll start by drawing 2 p orbitals oriented so that the lobes of the same phase can overlap, and then we'll indicate that overlap with lines connecting the 2 pairs of lobes. So a line connecting the 2 shaded or black lobes and a line connecting the 2 open or white lobes. The lobes must be in the same phase to overlap or to form a bond. We cannot depict a bond between out-of-phase orbitals like the ones I drew in red. And then remember that this overlap really looks more like pancakes or more like a pair of hot dog buns. And so you might see it depicted in this fashion as well, with 2 disc-like orbitals, halves of the orbitals, with the 2 nodes in between. Both of these drawings, the black and the blue drawings, are correct depictions of a pi bond resulting from 2 p orbitals. Here you're asked how many electrons occupy the bonding orbitals of a carbon-carbon double bond. A carbon-carbon double bond is comprised of 1 sigma bond and 1 pi bond. We'll draw the sigma bond first. And the sigma bond forms from the head-on overlap of 2 sp3 orbitals, 1 from each carbon. The pi bond results from the overlap of 2 p orbitals. We just drew this in the last question. We'll draw it again here. Make sure your orbitals are in phase. Then we just need to remember that each of these bonds houses 2 electrons. So combined, the bonding molecular orbitals of a carbon-carbon double bond will house 4 electrons.